Hey, good morning everyone. How are you all doing? Welcome to IGBits, a warm welcome for today. What is our slogan? We train, you learn. This is the best place for us to build a competency with basic builder. Is it? So we shall start our revision class today. Topic limits and continuity. This is what most of you actually asked us, right? So let's review. Without further delay, let's get started. We created a YouTube channel. Which does that our YouTube channel at the rate IGBits. Feel free to subscribe the channel. We started uploading all our sessions in YouTube. You can utilize this opportunity and build your competency. All right. Yeah. Thank you. Thank you. Whenever you talk about the limits, the first thing that we have to understand what is the limits mean, and then how we define, whether the limits are exist or not exist. That is how I think the concept would supposed to start. Fundamental mathematics, right? We know that left hand side equation is equal to right hand side equation, something like that. You can analogy from this concept. Left hand limit and the right hand limit is what we have to look at to understand for a given condition whether the limits exist for that equation. Think about that in general. Okay, what I'm saying is like limits are two categories, left hand limit and a right hand limit. If the both limits are equal, then we can say limit at a given point is exist, otherwise it does not exist, things like that. Okay, so when you say like left hand, if you say like a 0 is a reference, left to 0 is like what happens is like minus values, right? So if a given value is like a minus is like left hand limit, a plus would be the right hand limit. That is how you look at. Are you clear? See, let look at a simple way of giving a graph. Are you following me? So let's follow. So what we are trying to get you here. Imagine like one simple equation that you have, and then in the graphical representation, think about this way. And then you have some kind of curve. Let's say you can keep it this. This is x equal to a. X tends to a. Then this limit and this limit. This is a plus limit. This is minus. So between minus and plus, what would be your f of x function is what you are trying to say. Is it like a continuity function or a discontinuity function? Something like that you are describing, make use of the limits concept. We will see little more. Let's look at this example. Basically, this is a definition for limits in a way. Let's assume you have a f of x function, which is of x square plus 1. Think about this. This is like a behavior of the, this equation. So let f is r to r be a function defined by f of x equal to r x square plus 1. X belongs to r. If you say so, then think through from the right hand side and left hand side. When the x value, this is x, right? When the x value tends to 0, moving towards to 0, what would be your f of x value? Look at here. If x tends to 0, your f of x approaches 1. Even if you look at the right hand side, if x tends to 0, your f of x value reaches 1, approaches to 1. So from the left hand side and right hand side, both gives a equal value when x tends to 0, right? So limit x tends to 0, f of x would be 1. So this is how you have to understand. So this is a continuity function because the function exists at x equal to 0 is what we are saying. Clear? So you have to understand for a given limit whether the f of function is exist as a continuity or not. Think about that is how we are defining using this limits function. Let's look at this concept again with a different example. So you have a right hand side, the behavior of the curve, and a left hand side. F of x at the right hand side defined as a f of x is equal to 1 plus x when x is greater than 0, right? And then look at the left hand side. When x is less than 0, f of x becomes 1, is always like 1 is a constant value. Here the linearly increasing order. Now how do you define LHS and then LHL and RHL? Left hand limit and right hand limit you will just compare. You are describing this behavior. How the value of f of x where x less than 0. So when x tends to 0 would be f of x would be 1 when x tends to 0. When it is reaching towards to 0, the f of x value remains 1. So how do you define? Limit f of x tends to 0 minus equal to 1. So LHL becomes 1 when x tends to 0. That is what we define. Let's look at the right hand side also. The value of f of x when x greater than 0, right? The x tends to 0 is 1, meaning f of x value approaches 1 when x tends to 0 in case of x greater than 0. So we are talking about x greater than 0, which is RHL, right hand limit is what we are trying to do. In this case, when x tends to 0, f of x would become 1. So now case is LHL, you have 1 at x equal x tends to 0. RHL also, the value of fx is 1 at when x tends to 0. So both LHL and RHL at x equal to 0, x tends to 0 would be 1, right? It becomes 1. And hence what we are saying is that the limit of f of x when x tends to 0 is exist and its value is 1. So limit is exist. It is a continuity, right? Limit is exist is what we are saying. Are you clear? Let's look at this. Who is going to answer me? This is like a sigma function, right? Okay. So right hand function x greater than 0 is like an RHL. You have to find out a right hand limit when x greater than 0. And then similarly, you have to find out a left hand limit when x less than 0. So, and then tell me the behavior. So value of f of x when x tends to 0, how much? Minus 1. So this is what I am writing here. Limit x tends to 0 minus f of x value would be minus 1. Clear? This area is minus 1. Now do the same thing for right hand limit. Value of f of x equal to 1 when x tends to 0. Right? So f of x value defined as 1. Now tell me f of x in left hand versus like RHL. Is it same? Obviously no. You know why? This is a minus 1. This is a plus 1. That's why this a jump. Clear? So this is a, there is no continuity here, no? There is a disconnect. So you would say this does not exist. The limits of f of x when x tends to 0 is does not exist. That is how you have to define whether it exists or does not exist. In simple math, you look at a LHL, you look at RHL, see if the both functions are, both values are same. If both are same, then limit exists. Otherwise, limit does not exist. That is how you have to define. You will get like some of the questions to identify whether the limits are exist or not exist. This is how you have to compare. Clear? One more perspective. Let's look at like you have some kind of a the equation like this f of x function. Okay, and then you're talking about x tends to 0. Let's say you have somewhere else x is equal to a is what you were trying to find out for a given the point. What would be your f of x, whether the limit exists for it or not. How do you see a minus and a plus? Like initially what you were saying, like x tends to 0. Now you're talking about x tends to a. When x tends to a, how the limits for this f of x function, the value of f of x yet x tends to a. Again you have to apply LHL and RHL. So you give like a little step, minus h plus h kind of an interval, right? So if at all, if you look at a LHL, if at all f of a minus h, when h tends to 0 towards to a, if at all the value is L, some value, what I meant to say. Similarly, if you look at a RHL, f of a plus L, function f of x value at a plus h, where h tends to 0 towards to back. If that also gives like the same value, then how would you say LHL equal to RHL? In that case, you will get a finite value, right? The value is finite and then equal value. If so, then you say the limit exists at a given a for this f of x value. If the LHL not equal to RHL, then you say not equal, does not exist. So it's not that always you look for like an x tends to 0. There are the instances where you have the finite value, x tends to that value, where you can define your behavior of the function, whether it exists or not exist, things like that. We should be able to correlate and then give a proper answer. I hope you are clear. Some of the basic formulas which we use in limits, you can run through them, then we will be able to actually apply them for solving the problems under limits category. So limit x tends to a, x to the power of n minus a to the power of n divided by x minus a. If you look at the given problem statement something like this, then the answer would be n into a for n minus 1. This is the formula. Similarly, if you have something like this, x to the power of n minus a to the power of n divided by x to the power of m minus a to the power of m when x tends to a. If you look at this, then you have to say n by m, a to the power of n minus m. So both are, if you can correlate, I think you'll understand. But this is how I think you will be getting like a, sums. Sin x by x equal to 1 when x tends to 0. Whenever you see a given sum seems to be like a sin x by x form, then you can say like if x tends to 0, then the value will be 1. Similarly, let's say there is a multiplier, sin ax by x, limit x tends to a. When you have this one, the answer would be a, because if you can multiply a into a, sin x by ax is nothing but your 1, but multiply a becomes left over, the a into 1 is a. So tan x by x when x tends to 0 is 1. The limit tan x by x when x tends to 0, the value is 1. So the tan x by x value would become 1 when limit x tends to 0. Are you clear? Here x is basically like a radians. So if you look at here also, limit x tends to 0, the value of tan ax by x equal to a multiplier value. So these are the tricky things that we have to remember. Limit x tends to 0, 1 plus x whole power 1 by x is equal to e. You can look at this one, little variant, but the answer would be the same. Limit x tends to 0, 1 plus 1 by x whole power x. In this case also, the answer would be, the value would be e. These two cases we see. There are the sums which fall under this category, then immediately you can recognize this is a v. Okay, come back here. Limit x tends to 0, where e power x minus 1 by x equal to 1. This is also one of the formula that you have to apply. In 9th and 11th, you see, limit x tends to infinity, 1 plus p by q whole power qx. When the equation is something like this, then straight away you say this is e power pq. This would also be the same. Limit x tends to 0, 1 power px whole power qx. In this case also, your E value is PQ. All right. For a given, the problem statement, you have to always like figure out whether the given, sum is indeterminate form or the non-determinate form. Something like that we have to find out. If the 0 by 0, infinite by infinite, 0 multiplied by infinite, 0 over 0, or infinite to minus infinity, if you have like this equations, you will always remember, right? That's what we discussed. We always correlate them as a indeterminate forms. There are the cases where not indeterminate formats are 0 by infinite, infinity plus infinite, infinite over infinite, 0 over infinite. This we will get like a finite values. We will see when you look at a sample examples, when you rerun them, we will discuss on how these are actually going to be helpful for us, to find out a final answer. Okay, shall we move on to the next topic? All right. Tell me this one now. Limit x to the power 5, x power 5 minus 5 for 5 by x minus a. This is something like this one, right? The formula x minus x power a, x power n minus a power n by x minus a when limit x tends to a. What is the formula that we talk about? N into a power n minus 1. Now apply what is n value here? What is a value is 5, n is 5. So apply this one. This would become 5 into a is 5 and 5 minus 1 would be our answer, right? This is 5 into a power 4. Are you clear? That's an answer. Look at this one. It is not 0 by 0 form, but it is a straight through. Apply 1. 1 square plus 2 into 1 plus 3. Straight away we'll get to 1 plus 2, 3, 3 plus 6. Correct? Now look at this one. Limit x tends to 0, 1 by x square minus 3x plus 2. Apply 0. You apply 0, what happens here? 0 minus 3 or 0 plus 2. So numerator is 1, denominator is 1 by 2, so the value is 1 by 2. So at x equal 0, this function gives the value 1 by 2, the finite value. Here also at x is equal to 1, x tends to 1, the function value gives like a 6, right? So let's coming to here. Limit x tends to 1, x square plus 2 divided by x square minus 2. How do you define? Plug in the value 1 square plus 2 divided by 1 square minus 2. So 1 plus 2 is 3 by minus 1 equal to minus 3 value. Are you clear? This is how you can actually solve the limits problems in a short note. Look at the next problem. Limit x minus 3, x square minus 8x plus 15 by x square minus 1. If you plug in, what would happen? This becomes 3 square. 3 square minus 3 square is 9. 9 minus 9, 0. Something divided by 0, right? Something divided by 0. It's called infinite. So is it really true? We have to look at. How do you define then? You have to factorization both numerator and denominator. Then we figure out. So how do you factorize this value? X square minus 8x plus 15. We know that, right? How do you solve this problem? X square 15 into 1, right? 1 into 15 equal to 15. You can divide it. What happens like 5 into 3. 5 plus 3 is equal to 8. So probably this is 8. 8 can be written as 5x minus 3x plus 15. Then common x. So what happened this one? 1 minus 5. And x minus 5. Here for these two you can take 3 common, x minus 5, right? Then how do you write this one? X minus 5 and x minus 3. So the end of the day, limit x tends to 3, and then numerator we can say like x minus 5, x minus 3 divided by a square minus b square, we know that, right? A square minus b square equal to how much? A plus b into a minus b, correct? No? So likewise, if you say 3 square, right? X square minus 3 square, how do you write it? X minus 3 into x plus 3. Rewrite the same thing here, x plus 3 into x minus 3. Now you can cut this one. So what is left over? Limit x tends to 3, x minus 5 by x minus 3. This is what our simplified answer. Now you can plug in the value 3 minus 5, 3 plus 3. So minus 2 by 6. Is it? Minus 2 by 6 is nothing but minus 1 by 3. This is your answer. Are you clear? Well, let's find out whether the function exists at a given limit. What is a given limit? This one. This is a given limit. When a equal to 2, you see like whether function exists. Meaning straight away you can understand you have to define LHL and RHL. Whatever the equation would be. So now you see LHL, right? How do you write LHL? LHL would be limit x tends to 2 minus, right? The value, f of x value, how much this one? X by 2, correct? So what would be the value? You plug in 2 value, x plus 2, 2 by 2 is equal to 1, correct? Let's look at RHL, limit x tends to 2 plus. In this case, what is f of x value? X square by 2, x square by 2. Plug in the value 2 square by 2. It is nothing but 2. LHL, how much? LHL equal to 1 and RHL equal to 2. So LHL is not equal to RHL. So there is no function exist at A equal to 2 is what the conclusion made for this problem statement. Are you clear? So for a given interval, they are describing f of x function, how it seems to be at the interval a equal to 2 at the limit, and then x less than 2 value and x greater than 2 value is given. So the behavior can be defined by LHL and RHL. If the both values are finite and not equal, then you would be saying the function does not exist at a given limit. Clear? Alright, let's try out this one. X less than 0, x greater than 1, and x value between 0 to 1. And then given limit is like a equal to 1. Okay? So means like 1. So 1 plus 1 minus and 1 is what you have to define. So what would be your LHL? Look at LHL. Tell me. Limit x tends to 1 minus is what you are defining. What would be the value here? 1 minus ka value. So what you see, if you look at this complete, the limit funda, this is 0, this is greater than value, this is the less than value, right? And then a value between the 0 to 1. This is what is written. So it's between these two, you have a function. Right now, so whenever you say x value minus 1, what does it means? Like left to the 0. When the left to the 0, what will the equation? 2x plus 1. So let's look at it, 2x plus 1. 2x plus 1 value would becomes how much? 2 into 1 plus 1. So 3. Let's look at RHL. Limit x tends to 1 plus. How much the value? 3x, right? X is greater than 0, the value is 3x. So plug in 3x. How much? 3 into 1 becomes 3. Do you see that one? What did you find? Your LHL equal to your RHL. That means at a given limit f of x was exist, right? F of x was exist, yet limit a equal to 1. This is how you have to define. You clear? Next problem, limit x tends to 2 minus, where modulus of x minus 2 by x plus 2 is how much? This is a little tricky to understand. So modulus of x minus 2, right? So when we say x tends to 2 minus, what this means is when x is less than 2, x minus 2 would be less than 0, right? X minus 2 is the left hand side, LHL condition is given. Means like limit is a. So our condition would be x minus 2. I mean x less than 2. When x less than 2, x minus 2 would be how much? Negative value, right? So x minus 2 would be always a negative value. So x minus 2 negative. So what this implied is modulus of x minus 2 would be minus of x minus 2. This is what indirectly you have to understand. Now if you are able to rewrite this function, limit x tends to 2 minus, and then rewrite this minus x minus 2 divided by x plus 2. What the value? You can cancel them both and that remains minus 1. Right? Left hand value would be minus 1 is what is given when you ask these kind of things. Because you clearly stated x tends to 2 minus. Then what would be f of x value? So minus 1. Clear? LHL. Left hand limit. Try this one. We know one thing, sin ax by ax, limit x tends to 0. The value would be how much? 1. Correct? You can say like sin x by x also. Sin x by x equal to 1, limit x tends to 0. Let's look at this also. The x equal to 1, x minus 1. Right? X minus 1 become a. So limit x to the 1 x tends to 1 is also means like x minus 1 tends to 0. Think about. In this case, sin x minus 1 divided by x square minus 1. How do you write it? A square minus b square equal to a minus b plus a plus b. Correct? So in a way, if you write it, x square minus 1 equal to x minus 1 and x plus 1. So how do you rewrite this one? X minus 1 into x plus 1. If you look at this one, become a 1, right? Based out of this equation. So 1 into limit x tends to 1, x plus 1. That's what indirectly is given. So you can plug in the value 1 plus 1, 1 into 1 plus 1 equal to 2. So the answer would be 2. Clear? These two are the homeworks problems. You try out. In next class, we will discuss if you are not able to solve them. I'm sure it is simple thing and then you should be able to do that. Thanks for watching. Please like, share, subscribe, click on bell icon and leave the comments. We reached the end of session. Thanks for all who are actually joined today's class. I hope this class is useful. Try to spend some time, quality time in your preparation. Okay. Stay tuned to next session. See you tomorrow, guys. Okay. Have a good day.